why you stay firmly planted on the ground instead of floating off into space? It's a question that has puzzled humans for centuries, but the answer lies in an invisible force that surrounds us every day: gravity. It's the unsung hero of our daily lives, silently making sure that everything stays in its rightful place. Picture this. An apple falls from a tree, and a young man watches it tumble to the ground. This man was none other than Isaac Newton, and this seemingly ordinary event sparked an extraordinary realization. He understood that there must be a force pulling the apple downwards, a force that he later named gravity. Gravity, as Newton discovered, is a force of attraction that exists between any two masses. It's the reason why you're not currently floating off your chair and into the sky. It's the force that keeps us grounded, quite literally. But gravity doesn't just keep us from floating away, it also governs the motion of our planet and all the others in our solar system. Think about it. The Earth is constantly spinning, completing a full rotation every 24 hours. Yet despite this constant motion, we don't feel a thing. That's gravity at work. It's the invisible force that holds everything in place, from the tiniest dust particle to the largest planet in the universe. And what about the moon? It's floating in space, hundreds of thousands of miles away from us, yet it follows a precise path around our planet. How is that possible? Once again, the answer is gravity. It's the invisible tether that keeps the moon in orbit around the Earth, creating the ebb and flow of our tides. So the next time you take a step, remember the invisible force that makes it all possible. Gravity, then, is the unseen force that keeps our feet on the ground and our planet in orbit. It's the all-encompassing power that shapes our universe, guiding us on our journey through the cosmos. But why does gravity matter? What role does it play in our daily lives and in the universe? Let's begin with the basics. Gravity is that invisible force that keeps us anchored to the Earth. Without gravity, we'd float away. And not in a fun, balloon-filled party kind of way. More like an uncontrollable drifting into the abyss of space kind of way. It's gravity that gives weight to physical objects and causes them to fall towards the ground when dropped. But gravity does more than just keep our feet on the ground. It's the maestro that conducts the cosmic orchestra. Every time you see the sun rise and set, you're witnessing gravity in action. It's what keeps the Earth and the other planets in our solar system in their orbits around the sun. But its influence doesn't stop there. Gravity pulls swirling gas and dust together to form stars and planets. It's the architect of galaxies, shaping them into spirals, ellipticals, and other formations. It even bends light itself, acting like a giant cosmic lens. Our understanding of gravity has unlocked the doors to the cosmos. It has propelled us beyond our own planet, allowing us to explore other worlds both physically and through robots. It's led to the discovery of black holes, those enigmatic regions of space-time where gravity is so intense that nothing, not even light, can escape. Gravity is also a crucial player in the ebb and flow of the tides. The gravitational pull of the moon tugs at our oceans, creating high and low tides. It's like a cosmic dance between the Earth and the moon, choreographed by gravity. And yet, despite its pervasive influence, there's still so much we don't understand about gravity. It remains one of the greatest mysteries in science, a puzzle that scientists are still striving to solve. Without gravity, life as we know it simply wouldn't exist. It's the glue that holds the universe together, the invisible hand that shapes the cosmos. So next time you're out gazing at the night sky, spare a thought for gravity, the unsung hero of our universe. We've seen how gravity affects us here on Earth, but what about the rest of the universe? Imagine a cosmic ballet, where galaxies pirouette in an eternal dance, guided by the invisible hand of gravity. This force is not just about apples falling from trees or keeping our feet on the ground. It is the cosmic glue that holds everything together, from the smallest atom to the most massive galaxy. In the vast reaches of space, gravity is the architect of incredible structures. It pulls dust and gas together to form stars and planets. It herds billions of stars into galaxies, and galaxies into colossal clusters. But gravity doesn't stop at shaping matter. It also bends the path of light itself, a phenomenon we call gravitational lensing. When a massive object like a galaxy or a black hole gets between us and a distant light source, its gravity can warp the space around it. This causes the light to travel along a curved path, creating stunning cosmic mirages that astronomers can study to learn more about the universe's structure. On a grander scale, gravity is the driving force behind the universe's expansion. After the Big Bang, the universe began to grow, and it's been expanding ever since. But gravity, ever the cosmic glue, is trying to pull everything back together. It's a cosmic tug-of-war between the momentum of the expansion and the pull of gravity. In this astral arena, gravity is the unseen puppeteer, pulling the strings of cosmic bodies, dictating their movements and interactions. From the spinning of planets to the swirling of galaxies, every cosmic dance move is choreographed by the force of gravity. So the next time you look up at the night sky, remember that the beautiful spectacle you're witnessing is the work of gravity. The twinkling stars, the glowing Milky Way, the distant galaxies, they're all there because gravity has shaped, arranged, and held them in place. Gravity is like the cosmic glue, holding everything together and shaping the universe. It's a force to be reckoned with, a key to unlocking the secrets of the cosmos. Despite all we've learned, gravity still holds many mysteries. This invisible force, ever present in our lives, is the subject of ongoing scientific exploration and intrigue. Its secrets, once unlocked, could fundamentally alter our understanding of the universe. Consider gravitational waves, for instance. These ripples in the fabric of space-time were first predicted by Albert Einstein in his theory of general relativity over a century ago. Only recently, however, have we developed the technology to detect these elusive waves, opening up a whole new way of observing the universe. This discovery has been likened to hearing the universe for the first time, a cosmic symphony that has been playing all along, but only now are we tuning in. But the mysteries of gravity don't stop there. There's also the enigma of dark matter. This invisible substance, undetectable by our current instruments, is believed to make up about 85% of the universe's matter. We know it's there because of the gravitational effects it has on galaxies. But what is it exactly? That's what scientists are still trying to figure out. These ongoing quests remind us that despite our technological advancements and scientific breakthroughs, there is still so much we don't know. Gravity, as familiar as it may be, is still shrouded in mystery. It's like an old friend who, despite years of companionship, occasionally surprises us with a new facet of their personality. And that's what makes the study of gravity so fascinating.